Fine, guys. Okay, let's start. So yesterday we have started discussing the normal distribution, right? So fine. Now, as discussed, normal distribution is also called the bell curve. Fine. It's also called the bell curve. Fine. And yesterday we also saw this particular equation. What is this? This is a PDF. Okay. This is the PDF of the normal distribution. Fine. And these parts are called the tails of the normal distribution, guys. Okay, these are called the tails of the normal distribution, and usually normal distribution is represented as, so you can see something like this. Okay, because the only two things that are required, okay, to denote a normal distribution or to draw a normal distribution are what yesterday we have seen: mu and standard deviation. Agree? So as you change these two values, you can form new shapes of normal distributions. Yesterday we have seen, right? Yes, yeah. Yesterday you remember? Fine. How when you're changing the mu or standard deviation, how the graph is shifting. Agree? So I will also show you. Yeah. So let's see. See here. For example, see the blue color one. Okay, this is the original data, guys. Fine. And the orange color one is what we can change. So now observe, yesterday I have told you, what did I say? When you change mu, mean, what happens? Horizontally, the graph gets changed. Agree? And when you play with the standard deviation, vertically, there will be some changes. Agree? Do you guys agree? Do you remember these things?
Yes, yes.
Yeah. So now let's see those practically. So once you have this, fine. So if you see, and see now the mean is yeah, for example, if I put the mean as, yeah, yeah. So see over here, if you see, the mean is 0 and standard deviation is 1. Okay, for the original data. Fine, for the original data, what mean is 0 and standard deviation equal to 1. Agree? So that's why these two are overlapping. Now see, now when I play with the mean, if I increase the mean, okay, if I increase the mean, see what's happening? The whole graph is just moving towards right. Agree? But the thickness or the width of the graph is not changing. Okay, that means this one, the spread. So this is called the spread. Okay, that is not affecting. Only the whole location of the graph is either moving from here to or from one point to other point. Why? Because where will the mean? See, for this graph, blue color graph, 0 is the mean. So that's why it is over here. But now for the new graph, the orange one, I am playing with this. Okay, so now it will be at 5.90. That means somewhere over here. Okay, so now when I move this, see how it's moving. Fine. That means what? The mean is shifting. Okay, the wherever this middle point, right? The mean that is shifting. Agree? Agree? See, again, if I go to the minus, after 0 over here minus, okay, it is shifting. It is shifting how? It is shifting just horizontally. The whole shape is not getting affected. Okay, the shape is not getting affected, only the position is getting affected. Are you able to see clearly? See, the shape is exactly the same, only the mean is getting affected. Fine. But if I play with the standard deviation, if you see, okay, let me just come and put it over here. Okay. Now, if I play with the standard deviation, if you see, as I said, when you increase the standard deviation, the spread will increase. Agree? The spread will increase and it becomes fatter and fatter. See, as you can see, it is become fatter and fatter. The shape is actually getting affected. Okay, the shape is actually getting affected. Fine. But but if you decrease it, it will get peaked and peaked. Agree? See,
Yes, Santosh.
why did Shirisha get disconnected? Just give me a second. Uh, yeah, yes, sorry. Yeah, why did Sirisha suddenly disconnect? Hmm. Okay, fine. So now, anyhow, let's continue. So is this clear, guys? Are you able to visualize how the shape and getting affected when you play with this? But if you change the both, fine. I'm changing the mean also. I'm changing the standard deviation also. Fine. How it will affect. So like that, you can create n number of normal distributions when you change the mean and the standard deviation. Clear?
Yes, sir.
Okay, fine. Now, next thing is, yeah, Srisha, whatever, Srisha. Yeah. So next thing is, yesterday we have seen, yeah, yesterday we were seeing this example, right? So we saw this example, the light bulb example. Okay. So now we'll see one more example. Fine. See, suppose scores on a mathematic test are normally distributed. Okay. If the test has a mean of 55 and a standard deviation of 10, what is the probability that a person who takes the test will score between 45 and 65? Okay. See, what is saying? A mathematics test is connected and the scores are normally distributed. Okay. That means what? The scores are normally distributed. Fine. And it is having a mean of 55. Fine. That means what? Mu is 55. But standard deviation is 10. Okay. That means here it will be,
Plus or minus.
yeah, plus or minus 10. Fine. That means this is one standard deviation. This is from
45,
minus 10 to
65.
plus 10. This will be one standard deviation. So what will be this position now?
65.
Perfect. It is 65. This will be minus 10, 45. Agree? Agree? So now he's asking what is the probability that a person who takes the test will score between 45 and 65. Okay, 45 and 65. I want this area. Okay. So Megan, you remember yesterday you were saying like if I want to just have something in between, normally if I ask the cumulative probability of 45, what it will do? It will give less than or equal to 45. If I ask for 65, it will give you less than or 65. But if I want only between 45 to 65, what we need to do?
CDF, sir.
Yeah, CDF only. But if you go for CDF of 45, it will give you what? 0 to what are the minimum value? We don't know. Okay, if yeah, minimum values could be 0. It will give 0 to 45. So and the CDF of 65, it will give 0 to 65. I want only 45 to 65. What we need to do?
0 to 65 minus 0 to 45.
Yeah, correct. Yesterday we discussed, right, guys? Megan also told the same thing yesterday. You getting? CDF will always give from 0 to 45 if you ask for 45 and 0 to 65 if you ask for 65. But he's asking what is the probability he will score between 45 and 65. So this whole, if you take 65 area and from that means what, from 0 to 65. And if you take 45 area, that means 0 to 45. So if you subtract this area from this area, you will get only this 45 to 65. Okay, that's the point. So fine. So if the mean is 55, standard deviation is 10. Okay. Now you need to calculate the calculate what? normal distribution. Okay. So here my mean is 55. Okay, and 10, fine, and 65. Okay. Just a second. Oh, what's this? Let me take some. mm. Yeah, here is beautifully giving. See, when I say 0 to 45, so this area, whatever you are seeing, right? So here, I think here directly, you can give 45 to 65 also. But see, when I say 0 to 35, so see, what area, the blue color area he is clearly showing. Okay. So okay, how much that is? 0.1587. Fine. It is 0.159. Okay, that is cumulative CDF of 45 is 0.159. Okay, 159. Similarly, when you go for the 65, okay, when you go for the 65, 55, okay, 10, 0 to 65, fine, you will get the value of 65. How much it is? 0.8413. Okay, 0.841. So when you subtract these two, you will get the value area that is under 45 to 65. Okay, but I think in this calculator, he's also giving the range. So I think let's try to put this 55, 10, 45 to 65. Okay. Yeah, 0.6. Yeah, this is the area actually we want. Okay, 45 to 65. Fine. So same thing. Whatever we are doing, he's also doing the same thing. Okay. So you get 0.6826. Okay, 0.682. So we have the 68.2 is a probability that the person will get score between 45 and 65. Is it clear, guys? Is example clear? Will you be able to do some examples using the standard normal distribution calculator? Let me know, please. Any confusions?
No, sir.
No, sir.
Okay, fine. So now let's see some properties of normal distribution. So yeah, see, in a normal distribution, the mean and median and mode will always be same. Okay, what does it mean? See, the mean, median, mode will always be same, obviously, right? So what is this? In the middle, you have the mean, mu, average value. And what is the median? Median is the one which divides the graph into two. So obviously this should be the median. 50% will be over here, 50% over here. Agree? That became median. And what is mode? Mode is the one which is having the maximum frequency, okay, which is repeating the maximum number of times. And what is the y-axis? Y-axis is the frequency or the probability, you can say. So which is having, where you can find the maximum. You are having maximum here, okay, and that is over here. Okay, this particular value is repeating maximum number of times. So that will be the mode. Fine. So the one fundamental property of normal distribution is mean will be equal to median equal to mode. Okay. Second thing, symmetry about the center. That means around the mean, you will have a symmetry. Fine. 50% of the values will be less than the mean, 50% will be greater than the mean. Fine. The probability that x is greater than a is equal to area under the normal curve as shown by the non-shaded area. Okay, fine. The same thing. The probability that a particular value is x is greater than a. How you will get this? Normally, for the cumulative distribution, if you ask for a, what it will give? X is less than or equal to a, it will give. Okay, that means what? This x is less than a means this shaded area it will give. Fine. So, if you want greater than a, simply it will be the non-shaded area. Same thing which you have seen above. Fine. If you want x is greater than a, you don't have anything direct formula to calculate x is greater than a, guys. Try to understand. You don't have any direct formula to calculate x greater than a. But you always have x is less than a can be easily calculated from CDF. Okay, CDF will always give value or less than or equal to that value. So if you want to find out x is greater than a, simply you can calculate this x is less than or equal to a, and overall area will always be equal to 1 minus this one. 1 minus this will give you x is greater than a. Clear? I hope that is clear. Okay, fine, guys. So now after that, what we are going to see, yeah, so we have seen the streamlit visualization also. Okay, and we have seen the notation. Fine. So now, okay, yeah. So next we are going to study about something very important. But before that, if I just revise what did we study about normal distribution? Yeah, we have understood its shape. We understood why it's called bell curve. Okay, we understood what the main parameters of normal distribution. Okay, so make it crystal clear in your mind, guys. What does a normal distribution mean? Okay, it is if a type of PDF. You should not have any doubts regarding normal distribution going forward. Okay, it is a PDF function. Okay, which is for the continuous variable. Fine, and after that, the main parameters are mean and mu. Sorry, mu and standard deviation. This is a PDF. Fine, and we have seen it's like how mean and median, sorry, mean and standard deviation will affect it. Okay, that we have seen. And now, fine, and now we are going to see a special case of a normal distribution, guys. This is extremely important. Okay, see, focus here. Now, see here, it's called standard normal distribution, guys. Okay, it's also called standard normal variant because see here, guys, this is also normal distribution. This is also normal distribution. Agree? Now, this is also normal distribution. Fine. All these are normal distributions. But here is the catch. If there are thousands of normal distributions are possible, then one thing is it's great. Okay, we are able to, what we are able to do, we are able to find out a distribution which is very frequently that is occurring in the nature. Okay, frequently occurring in the nature. Fine. How do I say that? Because, for example, if you see, let's see some real life examples. Okay, see, when you talk about heights or weights of the people in the world, it is seen that it follows a normal distribution. Why does it seem obvious? It is simply because it is more probable to find the heights near the average rather than very short heighted or very tall people. Agree? The heights if you take, okay, what are the heights? Heights will be if the height of the heights will be in the range of 4 to 6. Okay, 4 to 6. Okay, for simply if you take 4, 5, 6, guys, this is the heights. How does the normal distribution look like? This will look like, it will look like, and simply without going into details, what is the fundamental point of normal distribution? Maximum value should occur at what point? Mean. Agree? That should be the point. You should be very clear. When you see here, this is the mean. Okay, the important point which you have just made is when I said mean equal to median equal to mode. Okay, mean equal to median equal to mode. What does the statement actually mean? What is the mean? Average. What is the mode? Mode is the most frequently occurring. Okay, median is anyhow it will divide into 2, but just focus on mean and mode. I'm saying mode is what? Mode is the value which occurs most frequently. The highest number of times occurring point is called the mode. And also I'm saying that is also equal to mean. That means the average value, whatever you are having in the x-axis, okay, the average value mean, that is the one actually which is occurring most number of times. Isn't it interesting? Now, if you apply the same thing to here, so in the heights concept, if you apply it, let me take 4 is the minimum height, okay, usually, and 6 is the maximum height. What is the average height, guys? 5. Now, average height is 5, and because it is normal distribution, you should also have, this is also mode. That means this should be occurring the maximum. So that is obvious, right? Because in the real life also, you will see people with very short heighted will be less, okay, less frequency, and also people with very tall, 6 above 6 will be less, but the average people will be seen with the most frequency. Most number of people will be falling with the 5. Is it clear? Are you able to understand how this height is following the normal distribution curve? Clear, guys?
Yes.
Similarly, now you can just expand this to, you don't need to confine to this example. You can just think of any examples and just try to understand whether the average values of that distributions, okay, are having the most frequent values. For example, take the weight. What is the weight? Normally, if I take some, let's say like 40 to 100 simply, and let's say some 65 is the average weight. Now, people having with 40 will be less, okay, and people having the obesity, let's say 100 is less, but the usual normal height, normal weight people can be found maximum number of times. So the average is also becoming what? Mode. Fine. That means mean is becoming mode. Fine. Majority of the values are found in the average values. So obviously that follows a normal distribution curve. Fine. So that is how this normal distribution got discovered or invented, you can say, because scientists got, whenever they are coming across different examples, right? So this one type of distribution is occurring multiple times. They are hitting this type of this shape distribution so many times. So then they started understanding why it is this shape is occurring most frequently, and they started understanding this. Then they gave the name normal distribution, and they started learning properties slowly. Now today we know almost 99.99% of every possible property, rules and regulations of these normal distribution, guys. Because why it became so famous? Because that is the one which is occurring mostly. Fine. So when something becomes famous, obviously, so that much market is available over there, right? That means that much frequently you can observe that. Fine. So if at all there might be some distribution like this, guys. Okay, this might be a continuous distribution. This is PDF. Everything is there. This will also have some PDF function. Everything. But what is the use of this function? Because I don't know what type of events will follow this. Whether heights or salary, or which type of random experiment will follow this graph. I don't know. Then what's the point of studying that? No, right? Everything you study should have some practical sense, right? So that's why normal distribution has so much practicality in nature. Fine. So that's the reason it became so famous. Fine. So it is simply the height is more probable to find the heights, okay, rather than the short. Just look around your class. You will find the majority of the people falling in the average height. Agree? Similarly, in the case of weights and IQ of the people also. Right, with the maximum height, if let's say the maximum height, Albert Einstein IQ is 140, and the least high IQ could be 80, you will find most of the people where average 100, maximum people, the frequency of 100 will be high, 80 will be low, 140 will be low. Obviously, this is also following normal distribution. Agree? Getting this? Fine. And also distribution of blood pressure. Everything will be normal distribution, guys. If you try to visualize, why? Because people having the extreme values will be less. Fine. Are you able to understand? People having the extreme, what are the extreme values? These edges are the extreme, either it is low or high. People having those will be obviously less. Even if you take the wealth also, wealth distribution also, poor people will be less, rich people will be less. But if you see the middle class, those will be the majority. Agree? Wherever you go, middle class like us will be the majority, guys. Fine. Because why? The wealth distribution is like that. Fine. So very rich people like Ambani will be very few billionaires. Fine, if that is a maximum value. And like extremely poor people in the slums, those will be like few. But most of the people will be moderately like wealthy. Agree? So that's why if you see, because if you see these values, okay, extreme value should always be less, because if you think about it, the society won't run itself, because if everybody is rich, then what's the point? If everybody is poor, then what's the point? Getting? Everybody can't be rich and everybody can't be poor, right? Everybody cannot be 6 feet high and everybody cannot be 4 feet. There should be maximum will be in the middle range. Agree? Getting, guys? everybody can't get like, for example, let's say 30 lakhs package, and everybody can't get like, let's say like 10,000. Most of the people will be somewhere around like 5 to 6 lakhs. Fine. If you observe, you will find tons of trends in your day-to-day life where majority of the people are falling in the average value. Okay. Is it clear, guys?
Yes, Santosh.
Okay, fine. Now, since we understood, okay, now we had got some confidence why we should study normal distribution. Fine. Now we'll try to see. So there is many advantages as we have seen. Okay, but the one problem, okay, not exactly the problem, but one like inconvenience could be, because, for example, let's say you three guys are there. So Meghana, Karthik, and Sirisha. Okay, Meghana is working on a normal distribution. Karthik is working on normal distribution. Sirisha is also working on normal distribution. Fine. But let's say you three of people have got three different normal distributions. Okay, because you can have n number of normal distributions. See, this is one normal distribution. This is another normal distribution. Now, if I change the mean, this is another normal distribution. Agree? So now, if three of people are experimenting something, and let's say you try to take some normal distribution, okay, just to observe some properties of that experiment. I don't know what is experiment. Fine, but unfortunately, all of you three got selected three different normal distributions. Fine, but since you are thinking that, okay, I am following all the statistics rules, like I took the continuous variable, and this is the PDF function, and obviously this is normal distribution. And if you carry out the experiments, all of your three guys, okay, all of your three guys, like let's say Meghana, Karthik, and Sirisha, all your results will be different from each other. Agree? All your results will be absolutely different from each other, because even though that is normal distribution, but they're not the same normal distributions, because Meghana's mean could be 0, Karthik mean could be 5, this could be -5. Agree? There will be shapes and forms, and everything will be different. Agree? So it is difficult. Yeah, Karthik, you're saying something?
But data is same, right? I mean, if you have three members are working on three different data, or uh, I didn't get that.
No, see, no, don't take it specific same data. So I'm just saying, you all want to let's say analyze the properties of a normal distribution. Okay, some normal distribution. Okay, you guys, okay, actually see, let's say, for example, let's say you are doing experiment, okay, roughly, and there is some requirements where you have to use a normal distribution. Okay, use a normal distribution. Okay, fine. There is a requirement in your project, for example, where you have to use a normal distribution, okay, and proceed with the next steps. Okay, just there is one requirement at some particular position to use a normal distribution. Now, there could be like n number of normal distributions, and each of you guys can take different types of normal distributions. Agree? So the results will vary. Agree? So the yeah.
Yes, Santosh.
Yeah. So now the problem here is we have seen, like, for example, scientists in USA might be working on some specific normal distributions. In Germany, they might be working on some other normal distributions. Fine. Although all those are normal distributions, I agree. But since we don't have any one standard normal distribution, obviously they cannot share the results. Right? Obviously, they cannot share. If this guy is working on a mu is equal to 5 and some other guy is working on -5, they cannot share the results. Fine. Even though I agree what you're saying. So if the data set is same, obviously they should use the normal distribution. So I'm not confined to the data set. Okay, roughly I'm saying, if at all, if you and me want to work on a same normal distribution, fine. If we both want to use the same normal distribution, then it is not possible, because n number of normal distributions are possible. Okay, so from here, most interestingly, what happened is, from normal distribution, what scientists have done is they have invented, all these are variants. Agree? This is one variant. As you change this from here to here and here to here, you can get infinite number of variants of normal distribution. Agree? But there is one extremely special case of normal distribution called as standard normal distribution case. Okay, standard normal variant, it's also called. Fine, this is a standard normal distribution whose, see, remember this, whose mean will be equal to 0, okay, and standard deviation equal to 1. This is the most fundamental thing you need to remember in the field of statistics. Okay, and this is called standard normal distribution. Getting? Okay, I'll just show you. Yeah. Okay, so if you just let me put it over here. Whatever. These guys. Okay, just let me take some other. Yeah, this works. This works great. Okay, fine. See this. For like ignore this Z, whatever you're seeing. Okay, we'll come to that. But see here, what is the mean of these guys? 0. What is the standard deviation? 1 width. 1 minus 1. This is 2 standard deviations. 2 minus 2. Agree? This is 3 standard deviations. 3 minus 3. Agree? Standard normal distribution is a special case of normal distribution where the mean will be equal to 0 and standard deviation is equal to 1. Always. Always. No doubts in this. When I say, now that is important. When I say normal distribution, you should ask me, sir, what is the mu and standard deviation for this normal distribution? Okay. But if I say standard normal distribution, no questions needs to be asked. It directly means mean equal to 0, standard deviation equal to 1, wherever you go. Okay. So now, if
Okay. Yeah, I have that. So if it is mean equal to 0, I mean, standard deviation equal to 1, then it should be only plus or minus 1, right? So we should not take minus 2, minus 3, plus 2, plus 3, right? I mean,
no man, see,
how that?
no, see, standard deviation, see, when someone says standard deviation equal to 1, it obviously means plus or minus 1.
Correct. But in this graph, we have minus 2, minus 3. That is also.
Hey, okay, see, don't get confused. When I say what is standard deviation? Standard deviation is not the endpoints. Standard deviation is what? It is one standard deviation.
Between, yeah. Got it.
Yeah, this is
One step on
only
standard
one
deviation.
step. It will only say from mean to, see guys, okay, let me explain it again. See, if at all you are having a normal distribution, observe, if you're having normal distribution, okay, if this is mu, okay, what will be standard, what is standard deviation? Rho. Then one standard deviation distance will be what? Mu plus rho. This will be mu plus rho.
Mu minus rho.
And mu minus rho. The distance from mu minus rho to mu plus rho is one standard deviation. Agree?
Yes.
Agree? This is one standard deviation. Okay, from mu to mu plus rho and mu to mu minus rho. This distance is called one standard deviation. Similarly, you can have second. What is second standard deviation? Mu plus 2 rho. Agree? Mu minus 2 rho. Getting?
Yeah.
Any doubts? Anybody apart from Karthik? See, make these things very clear, guys. When I'm saying mu, okay, if this, let's say this is average, okay, when I say standard deviation, okay, when I say standard deviation, it is just one standard deviation. When someone says standard deviation equal to 10 in these examples, see guys, don't get confused, please. When here mean is 55 and standard deviation equal to 10, what does this mean? This means there is a graph. Okay, this simply means, okay, the way you need to understand is, this simply means this is a normal distribution. Mean is 55. That means just this is 55. Okay. After that, one standard deviation is 10. Standard deviation is 10 means that it is one standard deviation is 10. That means this side it will be mu plus 10. Okay. That means from mean, one standard deviation is 10. That means from mean, it is one standard deviation is situated at 10 distance. Okay. That means from mean, if you go to 10, this is 10. Then how much this will be? Mean plus 10, mu plus rho. 55 plus 10, 65. Getting? And it will also be minus 10. That means from mean, it should be minus 10. 55 minus 10, 45. Getting? So when they say standard deviation equal to 10, they are not giving the point over here. They are giving the distance. How much distance one standard deviation is from the mean. When they say 55, see, I'll explain it again. No issues. When they say 55, they are saying it is actually the 55 is the point. Wherever you will find 55 on the x-axis, that is a standard deviation. Sorry, mean. Okay, that is a mean. But when they say standard deviation equal to 10, this is not the point on x-axis, guys. Standard deviation is equal to 10 means first standard deviation, okay? First standard deviation is at a distance of 10 from the mean. That means wherever the mean is there, from there, if you go 10 points, okay, there you will find plus rho, this is rho, and wherever you go, this point, you will find this is minus rho. Agree? And obviously, what this will be actually, from mean, you are going to 10 points. That means mu plus rho. This is actually mu minus rho. That means what is mean? 55. From 55, standard deviation at what distance? 10 plus 10, 65. This side, it will be minus 10 from mean. 55 minus 10, 45. Is it clear, guys? Is it clear?
So we need to stop only here as per data, or do we need to consider by imagining like plus two standard deviation? Like we need
You don't see,
other
you need
points
to,
as well. No need
yeah, you
to
need to
consider other
consider.
points.
Yeah, I got your point. See, most of the time, you will not have the data. In the examples which we have discussed, do we know the data?
Yes, we don't have.
In this light bulb example also, we don't know the data at all. He just gave the
Correct.
mean, he just gave the standard deviation, he's asking for a random value 1000. We don't know what all the values in the data. Here also, mean is 55, standard deviation equal to 10. We don't know the complete data. So it means you should understand that it will be one standard deviation, and there will be some more point. It will be at mu plus 2 rho. Okay. There will be one more point, mu plus 3 rho, like that. Getting? This side mu minus rho, mu minus 2 rho, mu minus 3 rho.
Okay. So we need to take ourselves by imagining.
Correct.
Yeah.
Correct. Others clear?
Yes,
Any
sir.
doubts? No doubts, right? Okay. Same thing here also. When you say mu, one standard deviation will be mu plus rho. This would be mu minus rho. Okay. The point from mu minus rho to mu plus rho will be the one standard deviation, guys. Don't get confused at all. Okay. Similarly, now that's why that is normal distribution. That is normal distribution. Okay. Same thing. Same thing. What is standard normal distribution? Standard normal distribution is a distribution which will always have mean equal to 0 and standard deviation equal to 1. Okay, mean equal standard deviation equal to 1. See, normally, what is one normal standard deviation distance, guys? It is from mu minus rho to mu plus rho. Here you will have mu. This one, mu minus rho, mu plus rho. This is the one standard deviation. Agree? Agree this point?
Yes, Santosh.
Now in the standard normal distribution, what is the mean? 0. Now put 0 over here. It will become 0. And standard deviation equal to plus or minus 1. It will be 0 plus 1. And here it will be 0 minus 1. Now what it became? This is minus 1, 0, plus 1. From minus 1, 0, 1. See, minus 1, 0, 1. This is one standard deviation. Got it?
Yes.
No. Tell me if you really understand. If it is confusing, that's fine. I'll explain it again.
Yes, understood.
Okay. See, guys. See. Don't get confused. It's simple, actually. Simple. See. When I say standard normal distribution, it is just a special case of normal distribution. That means what? What all properties this normal distribution having, all those should be definitely applied to standard normal distribution. Standard normal distribution did not fall from sky. It is just a special case of normal distribution. So what all rules and formulas that are applicable to normal distribution, that should be definitely applicable to standard normal distribution also. That is point number 1. Simple. When I say normal distribution, this can take any mu, any row. There is no limit. As we have seen in the diagram, anything is possible. But when I say standard normal distribution, there are no options. Mean should be equal to 0. Standard deviation should be equal to 1.
1.
Second point. Clear? Are we good till this point?
Yes.
Okay, cool. Now, after that, now what I'm saying here is, see, observe here. Observe here very carefully. Okay, here, let me write it as mu equal to 0. Sorry. Standard deviation equal to 1. Observe. Whenever you take a normal distribution, observe my words carefully. I'm saying normal distribution, not standard normal distribution. Okay. Now, here it will be, in the middle, you will have mu. I don't know what is the value of mu. It could be 10, 20, 100, 1000, 1 lakh. Forget about it. But in the middle, you have something called as mu, mean. Fine. So when you are having mean, it will be in the middle. When we say one standard deviation, that means it is distance of plus row and minus row from mean. Okay. When I say standard deviation equal to 10, that does not mean you should point, you should place wherever the 10 is on the x-axis. No. Standard deviation is, the word itself is saying how much it is deviating from the mean. Okay. That means from mean, if you go one standard deviation distance, okay. Now this will be mu plus one row, one time row, or simply 1 into row. Okay. This is one's plus side and this is minus side, mu minus row. Okay. This mu minus row to mu plus row, this distance, okay. Okay. This distance, guys, on the graph, this distance is one standard deviation. Are we good till this point?
Yes.
Okay. So now when someone says for this normal distribution, okay, mean equal to 10 and standard deviation equal to 2, for example, that means this is 10 and okay, standard deviation equal to 2. This is 10 and the standard deviation is mu plus row. Okay. That means what? 10 plus row, 12. And this is mu minus row, 10 minus 2, 8. Agree? Always mean will be in the middle between these two. Fine. So from 8 to 12 is one standard deviation distance. Clear? Standard deviation is how much it is deviating from the mean in the positive side and also in the negative side. That is what the meaning of the standard deviation. It will tell you what is the distance between mu and this mu plus row, first row, and mu minus row, plus or minus 2. Is that clear?
Yes.
Others also. Meghana, Sirisha?
Yes.
Yes, sir.
Perfect. Now they will say only standard deviation equal to 2. Now we should understand, okay, one standard deviation will be mu plus row and mu minus row. You got 8 and 12. Fine. And second standard deviation will be what? Mu plus 2 row. Right? 2 standard deviations, 2 into row. Getting? And here it will be mu minus 2 row. Getting? How much it will be? 10 plus 2 times row, 4. 14. Clear? it will be 10 minus 4. How much? 6. Okay. Now you got 6, 8, 12. Sorry, 6, 8, mean is 10, 12, 14. You got the points? Like that, you can also calculate mu minus 3 row and mu plus 3 row. Okay. You need to calculate this. To calculate this, you just need mu and standard deviation. Mu is the mu, and with the standard deviations, you need to calculate these points: mu plus row, mu plus 2 row, mu minus 2 row, mu minus 3 row. Okay. Is it clear?
Yes, Santosh.
Let me know if any doubts. So here now, if you observe very carefully, when I am doing this, I said, sorry, this is mu, and one standard deviation is what? If this is mu plus rho, and this is mu minus rho. Clear? Now see, this is what? This is for a normal distribution. Any normal distribution you take, put that mu, put that rho, you will get one standard deviation, two standard deviation distances. Okay. But now, because you cannot study thousands of normal distributions or infinite number of normal distributions, we want only one single normal distribution which can be used across all the scenarios. Okay. Every time, why we use formulas, guys? Because they work every time. That's why we want something to work every time. Okay, so that's why it's called, we have standard normal distribution whose mean equal to 0, standard deviation equal to 1. Okay. Now see, but standard normal distribution is not a completely different distribution. It is just a special case of normal distribution. Agree? That means what all properties which we have just discussed about the normal distribution, all should and must be applicable to the standard normal distribution also. Agree? The only special thing about standard normal distribution is its mean will be equal to 0, standard deviation equal to 1 every time. Okay, these two are the properties of standard normal distribution. That's it. Apart from that, it is also same as normal distribution. So here, if you see, if you apply this thing to standard normal distribution, now what will be this mean will become 0. Now mu plus rho, 0 plus 1, 1. Mu minus rho, 0 minus 1 minus 1. Agree? This is one standard deviation distance you got. Now second standard deviation is what? Mu plus 2 rho, mu minus 2 rho. That means mu plus 2 times rho will be 0 plus 2 into 1, 2. It will be 2 minus 2. Here it will be 3 and minus 3. Okay, mostly we will take till 3 only. Why we will take mostly till 3? It is we have excellent reason for that, which we'll be studying just in few minutes. Okay, but you can go till any point, but mostly we'll go till 3. Agree? So like that, you will have these values. So now if you observe carefully, whenever we are drawing standard normal distribution, directly you can have these values, because nobody need to specially tell you that, hey, mean equal to 0, standard deviation equal to 1. No, because when we say it is a standard normal distribution, obviously the mean will be 0, standard deviation equal to 1, and you can just come here, replace these values, you will get these values. So that's why when you say standard normal distribution, the values are by default given. Fine. It will be 0, it will be 1, 2, 3. It will be minus 1, minus 2, minus 3. This will be the standard normal distribution every time. It's standard. Getting?
Yes.
Is standard normal distribution clear, guys? Okay, fine. So observe carefully. Now, hey, are you guys going to college?
Yes, going.
Oh, okay, fine. Let me take some minutes. Okay. See, this is standard normal distribution. Fine. So now the interesting point over here is, if you're having a normal distribution, okay, if you're having a normal distribution, and here the mean and standard deviation could be anything, but there is special case you're having standard normal distribution, okay, where mean equal to 0 and standard deviation equal to 1. Okay, now there are two things we need to discuss. One is how does the standard normal distribution is making our life easier? Okay, first point. Second point is, if standard normal distribution is so important, I mean so famous and so useful, is there any way through which we can convert any given normal distribution into standard normal distribution? Getting? We are saying, okay, standard normal distribution is very useful because it is very simple. Nobody need to give any special values of mu and 0, and it's always equal to so mu and standard deviation is 0 and 1, and this will be the graph. Okay, I know most of the details about this. Okay, now if it is so much important, what are the use cases of it? First thing. Second thing is, now is there any way to convert my normal distribution into standard normal distribution? That is important. Agree? Because in day-to-day life, as I said, you will see so many normal distribution events, height, weight, etc. Sorry. Agree? But all those are just normal distributions, guys. They are not standard normal distribution. Agree? If you take height is a normal distribution. Agree? It is not a standard normal distribution. Okay? If it is a standard normal distribution, then the mean should be 0. But it doesn't make any sense that anybody's height could be 0. Agree? It is a normal distribution. Even weight. Normally, nothing will be 0 in real life. Fine, the mean will not be 0. Fine, it is all normal distributions. But we have studied standard normal distribution and understood it is very important. So, is there any way to convert normal distribution into standard normal distribution? That is one thing you need to understand. Okay? But before going there, let's try to understand what is the importance of the standard normal distribution. Okay, fine. We are saying, okay, instead of studying all the normal distributions, we have one standard platform now where these are the values always. Okay, then what is importance? Can you show me? Okay, for that you have something called as Z tables, guys. Okay, Z table. Okay, now before before trying to understand this, okay, so let's see some examples. Okay, for example, if you see, okay, so see the standard normal distribution is special case of the normal distribution. It is a distribution that occurs when a normal distribution has a mean of 0 and standard deviation equal to 1. Okay, it is a mean of 0 and standard deviation equal to 1. Fine. And before that, I need to explain you. Okay, how much time actually do you have, guys? Based upon that, I will plan whether to discuss this or start. Do you have 10 minutes? Oh, I'm asking Megan and Sarisha.
We are going to college, sir.
Oh, okay, fine. Are you guys okay to join tomorrow? Or do you want a break?
Monday, sir.
Monday. Okay, fine then. Okay, guys. So fine. So just I have shared the notes, right? So go through that notes, and after that, so go through the normal distribution part. Okay. I hope normal distribution basics are clear, and we have started standard normal distribution. Okay. So in the next class, right? In the next class, we'll understand how you can convert standard normal distribution into standard normal distribution, and how it is helping the standard normal distribution. And also, we are also going to see something very important called as empirical rule. Okay, which is the very important role in the standard normal, in normal distribution. Then you will understand why we are taking only till 3. Okay, so if you observe, I was taking only mu plus 2 row and mu plus 2 minus 2 row and mu plus 3 row, mu minus 3 row. Okay, why we are taking only these 3? And then once we discuss empirical rule, you will get a complete picture in your mind about normal distribution, standard normal distribution, and the importance of this empirical rule, and also some properties of that. Okay. Okay, fine. Let's try to conclude this okay, on Monday. Fine. So once we complete the normal distribution, right? So I think we will be completing one extremely important concept, normal distribution, and we have already discussed uniform distribution, right? Fine. Yeah. we already discussed something called as uniform distribution. And if I go over here, yeah. So then we have some, yeah, we'll discuss the binomial distribution, Poisson distributions, and T distributions. Okay, fine. All these are, I would say, not that important. You will not see that frequently, but normal distribution is the one which you should be extremely good at. Okay. So I strongly recommend you to go through the class, make some notes, and come prepared on Monday. Fine. So that we will try to conclude normal distribution on Monday. Okay. Fine. Are we good, guys? Any confusions? Let me know honestly. Are you able to understand the concept? Any confusions, or am I going too fast, or are we good?
I'm fine, Santosh.
Okay, fine. Okay, guys, fine. Then take care. We'll meet on Monday, sharp 6:30. Thanks, guys. Bye.